All right, so let's talk about confidence intervals where we have one sample or one variable, and we're looking at variance and standard deviations. So again, the idea, sigma or sigma squared, we don't know it, we want to find it, so what are we going to do? We're going to go out, take a sample. From that sample, we'll get S or S squared, right? The standard deviation or variance of the sample, and we'll use that to make a guess or an inference about the population. So our steps for a confidence interval, if we don't have S or S squared, we need to calculate that from our sample. To be able to perform the test or to create the confidence interval, the population must be normal. Then we need to find the critical values, and then from there we can use the formula to find the confidence interval. All right, just a reminder, whatever your confidence level is, remember that always goes in the middle. So if I'm thinking of a 90% confidence interval, 90% goes in the middle. What's left? 10%. So if I split that in half, that would be 0.05 or 5%. That would be 0.05 or 5% on that side, right? And we do have to look them up on both sides because it is not symmetric. And here's a screenshot of that. If you were using StatCrunch, if n is 18, that means the degrees of freedom is 17, n minus 1. So get those in there. And here it was a 95% confidence interval. So that's 5% left over. And with 5% left over, that's 2.5% on each side. And so we looked up both of those, and you can see you get your two confidence levels down here. So there they are. So pretty straightforward stuff, but you do have to look them both up because it is not symmetric. Otherwise, here's your formulas. Pretty straightforward. N and S or S squared come from your sample, and then the bottom is the critical values. And really, these formulas are the exact same because if you took the square root of each of these, that's how you get the formula for standard deviation down below. So really, it's just one formula, thinking of just kind of square rooting it to get the other. So, or if you start with the bottom one, you square everything, you get to the top version. So that is the formula. So let's give it a shot. Let's do two examples real fast. So we got a medical study finds that in a sample of 27 members. Okay, so first of all, n is 27. So by the way, that means the degrees of freedom is going to be 26. Anyhow, the sample mean systolic blood pressure is 114.9 with a sample standard deviation of 9.3. Find a 90% confidence interval for the population variance and assume the population is normally distributed. So that takes care of my conditions right there. A couple things to highlight. Sample of 27. Okay. Sample standard deviation of 9.3, 90% confidence interval. And they want us to find confidence interval for the variance. Now, by the way, they talk about the mean systolic blood pressure of 114.9. We actually don't need that. Okay, we don't need the mean to be able to create a confidence interval for a variance. All right, so let's find those critical values. So in general, gonna look something like this. And what we were using a 90%. So that means there is 10% left over. Split that in half. That means this is 0.05. This is 0.05. So we need to look up the critical value for the left and the critical value for the right. And we'll do that in StatCrunch. So let's check that out in StatCrunch. Stat calculators chi-squared. Degrees of freedom was 26, and so then I'll look up 0.05. So that's going to be 15.379. Okay, And then we'll do the same thing for the other side, because again, it's not symmetric, so we have to look up both. So 38.885. Okay, so there we go. We got our confidence intervals back. All right, and there are our not our confidence interval, our critical values. So there they are. And so then if I need the formula, they wanted the interval for variance, and so for variance that would be sigma squared, and then that would be, what is it? Remember, it's right here. So n1 minus s squared over critical value, but it's the opposite. It's actually the right hand, and then this would be n1 minus s squared over the left-hand critical value. And I do have all the values, so I could sub those into the formula. So n was, let's see here, what was n? N was 27, so n minus 1 is 26. S squared was 9 point, S was 9.3, so that would be 9.3 squared. Again, this would be 26. This would be 9.3 squared. And then our critical values, 15.379 and 38.885. And then you could work this out. Okay. I'm actually going to do it in StatCrunch, so let me show you how to do it in StatCrunch. And so if I go over there, we'll go to Stat, Variance Stats, one sample with a summary. My sample variance, let's see here, 9. Remember, they gave us standard deviation. StatCrunch only uses variances, so 9.3 was my standard deviation. If you work that out, 9.3 squared is 86.49. Sample size was 27. And then you can tell it, hey, I am doing a, I think it was a 90% confidence interval. And so there it is, pops up the answer. So 57.83, 830, I guess. And then 146.21998, so we'll say 146.220. Okay. So there is my confidence interval. So I am 90% confident that the true population variance is between these two values. Okay, so there's a confidence interval. All right, let's go a little bit faster this time. So we randomly select and weigh 30 samples of an allergy medicine. The sample standard deviation is 1.2. That is S, so S is 1.20. N, by the way, was 30. So first of all, that tells me the degrees of freedom is 29. We need to use variance if we want to use StatCrunch, so I need S squared. 1.2 squared is 1.44. And assuming the weights are normally distributed, that takes care of my conditions. That means I can do the confidence interval and use chi-square distribution. Construct a 99% confidence interval for the population standard deviation. So again, this is 99% in the middle. That leaves 1% left over. Divide 1% in half. That is 0.005, half of a percent, 0.005. And so we're going to look those two values up in the calculator. I have the calculator open, so let's just do it. So N was 30, degrees of freedom was 29, 0.005. So the one on the right is at 52.336. The one on the left, delete that out, flip it back. 13.121. And now we want a confidence interval for what? Standard deviation. Okay. So I could use StatCrunch for this, and I'm going to do that. But remember, StatCrunch only works with variances. So the numbers I'm going to get for StatCrunch are for variances, sigma squared. So let's go ahead and type our values into StatCrunch. Whoops. There we go. So they were my critical values. And there it is. The variance, the interval I'm going to get from StatCrunch is for variance, which is sigma squared, right? So, forgot to flip my screen back. So here we go. Let's go ahead and do this. So again, if I was starting from scratch, it's stat, variance stats, one sample with a summary. Sample variance, that was 1.44. Sample size was 30. And I wanted a 99% confidence level. Hit enter. There it is. And so it gives me an interval from 0.7979. So we'll say 0.798 to 3.183. And that is for, again, for the variance. So if I flip back over here, it gave me that interval. But again, I want a confidence interval for standard deviation. So I need to square root, square root, square root to turn all of these into a confidence interval for a standard deviation rather than a variance. So if I just take the square root of each of these numbers, so the square root of 0.798, that's 0.8933. And if I take the square root of 3.183, that'd be 1.784. And there you go. So I am 99% confident that the population standard deviation is between those two values. All right. So that concludes doing confidence interval with a variance. So pretty simple. Biggest thing is just remember StatCrunch only uses variances, so be careful.